Good afternoon, this is Schweitzer, and we're run through, we're considering it's called factor, label, or what are linear relationships. So in our everyday life, we have lots of linear relationships. We know it so well, we just maybe not even recognize what it is. Say, for example, you go to work and you make $9 per hour. This is a linear relationship. If you're driving and you're going 70 miles per hour, that's a linear relationship. So if you were to track these out, or graph them out, you would see that if time and distance were traced, for example, someone going 70 miles, and if this were just hours, then you would be traveling, in 1 hour. 1 hour it'd be 70 miles, and 2 hours would be 140 miles, and you just get this, this straight line. That's what we call a linear relationship. It always kind of threw me as a kid that, 60 miles per hour. That was always one that always kind of stuck with me, because there's 60 minutes in an hour. So you're going 60 miles in 60 minutes. So you're going 1 mile every 1 minute, and it's kind of an interesting little relationship. You can drive past the mile markers and you can test it out. When you're on the highway, if you have a timer, if you have obviously not driving, but you could. It's a unique one. Okay, so if you're going faster, then this is less than more than a mile per minute. So these are just relationships, and so maybe sometimes if you're at work, you'd be able to, if you don't like your job, you can still calculate how much money you're making. 1 hour I make this much, 2 hours I make this much. So in reality now, of course, the idea here is that any kind of math, math and science, these are not history classes. We're all about predicting tomorrow, okay? We want to know the future. And that's all we're really concerned about. If we can't predict the future, then what's the point? So let's say, for example, you want to drive to Milwaukee and you're driving at this speed. I want to know if I have to go this far, how long will it take me? And I can predict ahead of time. Alright, so can we solve these problems? Why or not? Okay, so this is a common thing that's kids sometimes are memorizing things and not looking at the big picture and missing things. So what's wrong with these? Bob makes $9.50 an hour. How much money does Bob make? Sue drives 80 miles per hour. How far did Sue drive? A soup recipe uses 2 onions. How much soup was made? So all of these are we call just relationships. And for many people, this makes perfectly good sense in things that are in everyday life. But keep in mind, these are all just relationships. $9 per hour, it means nothing. It's a relationship. You could make $900 per hour, like, ooh, wow, I must make a lot of money. You don't know that. Maybe you worked 1,000 hours and you made, $9,000. So you make a lot of money, but it's just a relationship, or I might even call it, I sometimes call it a flipper. All this thing does is flip dollars to hours, or hours back to dollars. So that being said, when you have a relationship here, it means nothing. So if I give you some random thing like grams per mole, then this really means nothing, except for if you have 1 mole, you would have this number of grams. You could say, for example, 32 grams per mole. Now, you have no idea what a mole is, but you should realize just mathematically that 32 grams equals 1 mole. We call these things relationships, but we also call them equivalencies. Okay, they're equivalent. Meaning that an hour doesn't mean dollar, but in the scenario they're working with, 1 hour equals $9 in pay. Okay, so a top-bottom relationship, just equivalency. So the next question could be, how many grams do we have? Well, you don't have any grams. This is just a relationship. And you should be able to, after we're done with this, have no idea what a mole is. Yet you should be able to convert with this thing grams to moles and moles to grams, regardless of if you know what a mole is or not. Okay. So with that being said, keep in mind what relationships really are. All right. So Bob makes $9 an hour, and the manager Tom makes $22 an hour. So we're going to take a moment here and let's take one and just graph this out. Okay. I got some old data in here, and you can graph it out on your own. I'm going to go pretty quickly on this stuff just so you can see it, but you should pause it and try it on your own. Okay, we likely will do this in class, and you can create your own scale money-wise, but really it comes down to just doing a little bit of simple math. 1 hour, so we'll go, let's just take, it says to do the first 8 hours. Okay, maybe we'll change that to first 4 hours to make it a little bit easier. What I might do, let's do 1 hour, 1 hour, 4 hours, and 8 hours. Okay, so 1 hour Bob makes 9, Tom makes 22. 4 hours, and you could do just do 2 hours here too. It'd be 18 and 44. So you can grab your calculator here, and you can easily punch out the dollars per hour. And in this case, 4 times 9 is 36. 4 times 22 is 88. And then 8 is going to be 30. 9 times 8 is just your 72. And again, you could do all of them. We might do it in class too. Good enough. And then 8 times 22 is 176. So as we look at this thing here, this could be dollars per hour, or it could really be miles per hour, right? I mean, it's just a relationship. So you mark out your times here and your hours. Maybe we'll do 8 hours, and then you'd see that after a while, Bob, let's do Bob in blue, and Bob would have something like this for 22, and then 1, 2, 3, 4 could be 44, could be like right here, and we might take a little more time and actually mark out our range here, and then 8 would be 176, so 1, 2, 3, 4, 5, 6, 7, 8, and 176 would be probably right about here. And this would be his rate of pay. Rate sounds a lot like relationship, and that's what we're talking about here. So let's go with orange here for Bob, for Tom. So Tom makes 22, so he's a little bit above this guy here, so it's going to be like right there. And then he's doing 44, would be like right here, and then eventually he's going to be 8, he'd be up here, okay, and it's going to be just tricking along like so. Alright, do the best I can to keep that straight. So again, a couple things here. Bob makes $8 an hour, the man makes 22. List out how much Bob and Tom make over an 8-hour shift. So in this situation, what we're doing here is we're just tracking it out. Now the glorious thing about math is, again, you can predict the future. So a graph has what we call a direct read. And I could say, okay, if I grab my pen, I could say, okay, well, how much time will it take for Bob to make, X amount of dollars? So I could say, well, if I want to make a certain amount of dollars, come across here, and then come straight down. That's the time right here that Tom makes that money. For Bob to make that same amount of money, all right, now I'm going to have to, we call extrapolate that line out. Okay, this line here is going to be Bob's line. And I could take this guy and cut across here and say, well, now, this is the amount of time that it's going to take good old Bob with his $9 an hour to make the same amount of money. And, we want to make sure that we understand that idea. I'll grab a pen here. Okay. That this is all about predicting the future. Sometimes we call this a direct read. It's just a term. It doesn't mean much. Ream. We're just reading a graph. Okay, but we extrapolate. Extrapolate is another term that is going beyond. There's also extrapolate, or you can even go. Let's say we have data points here. You can interpolate. Go this way, and say, well, if I only work this long. And also, you could say, well, what if I work 4.5 hours? Okay, I don't even have a data point between those guys for that point, but I can use the relationship to say, okay, well, if I only worked 4.5, I can still estimate between these 2 points. Okay, so math is powerful. We use it all the time. All right, so let's move along here. Can Bob and Tom predict how much money they'll make in 40 hours? And the answer is yes. So how could they do this graphically? Answer this question. Again, we just did this on the last question, on the last page. Okay, and I should move this page up. So how could they do this mathematically and predict this? This is our first introduction we call factor label. Pay close attention to this. Okay. Yes, this will seem easy. Now, this is the part where it's going to seem easy now, but when chemistry gets tougher, this gets tougher, and we need to rely on good habits. So starting good habits now means that when we get into the chemistry stuff, this stuff you're not winging it. Okay. So here we go. So how much will Bob make in 40 hours? Again, I don't give a hoot how much Bob makes in 40 hours. Okay. Bob's a make-believe dude, all right? We don't care how much Bob makes. It's all about this process. So it's not even about the answer. I don't even give a hoot about the answer. The answer means nothing. I didn't even spell the answer right, and I still don't even care. The answer, the only thing we care about is, can you set this up, and can you start developing a solid habits and get this process down, so when we start using it in chemistry, you just click right through it. Okay. Here we go. How do I solve this? Well, first of all, I start with 40 hours. And I start using my relationships. Okay. I sometimes call this the dot line method. Mrs. Jackson likes to use railroad tracks. I like that too. It doesn't matter. So this unit has to cancel out and go to another unit. My plan is just to take my hours and just flip it to dollars. And I'm going to use the relationship of dollars per hour. It's just one relationship. So I get rid of hours and I go to dollars. And of course, this is just going to be the dollar-hour thing that Bob makes. It'd be 1 hour is equivalent to $9. And 40 times 9 equals how much? Okay? So 40 times 9 equals, now here's the thing. Anytime you have a number on top, okay, you would be, okay, multiplied. If you have a number on the bottom here, you would divide those numbers, and that's really important. So, for example, here, 40 times 9 divided by 1 is $360. Okay, let's try Tom once. Now, Tom makes $22 per 1 hour, but I'm going to change that relationship. I'm going to leave the same thing. Tom actually makes $11 every 0.5 hours. Does that make sense? Is that the same? Yeah, it is. These are the same relationships. I'm going to use this one, give you just a little look at it. So in 40 hours, okay, 40 hours, how much does Tom make? I can use either one of these, but I'm going to use the bottom one. Get rid of hours and go to dollars. Okay, so now I'm going to use this guy. So he makes $11 in a half an hour, 0.5. Okay, so I'm going to use this to sort of just extrapolate the idea that I need to multiply the top number, okay, and then divide by the bottom number. So you grab your calculator and you just go 40 times 11 divided by 0.5.
Okay, now in this situation, I don't need to push equals either. Just 40, all right, times 11 divided by 0.5 equals. It doesn't even matter what order I do this in. I could divide by 0.5, multiply by 11, doesn't matter. Equals $880. Again, the number doesn't really matter unless you're Tom and you want to know how much money you make. Okay. Now, this is just a linear relationship. So, can we just use ratios? And the answer is yes. This whole thing is just a ratio. And ratios you learn back in like 4th grade. Now, we're going to be stacking lots and lots of ratios on top of each other in this process, okay, which is the only reason why we care about this, is to stack these units, to cancel units, to help make it easier to work through the ratios. But occasionally there's a couple of kids who just use ratios. So a linear ratio looks something like this. X over Y equals X over Y. This is a linear relationship. X could be dollars and Y could be hours. So let's try this out once. Let's say, again, this is just a tool that flips. So I'm going to use, let's say, Bob again. Let's do $1,000. Let's take something else. Let's do 500 hours. Let's say Bob works 500 hours over the holidays. Okay? You could say, let's do this instead. Okay, let's say Bob needs $5,000 to buy a car he wants to buy. Okay? For a car. How many hours does he need to work to get that to happen? Okay? And you could also compare it to Tom. How many hours Tom has to work? So this is what we're going to do. It's going to be a relationship looking like this. And I'm going to put dollars on top and I'm going to put hours on the bottom. And I got to use my relationship. This is the known relationship, $9 per 1 hour. And the top is dollars, the bottom's hours. So I'm going to put in the 5,000 here. And I'm going to solve for the 1 hour, so for this guy. Now on this guy here, I can cross multiply and divide. Okay? And in this situation, that would be fine. 5,000 times 1 is 5,000 divided by 9 is going to be 5,000 divided by 9, and we get 555 hours. Okay? Question mark equals 555 hours. Now, let's look at how much time it takes for Tom to get this. Now, I'm going to do this a little differently. Okay? I'm going to go dollars per hour, okay, equals, okay, now, dollars per hour, okay, per hour. So I want to show you the algebraic way of doing this. And things move diagonally, okay? So I want to solve for this guy. As long as we're not doing addition, subtraction, we just move what I want around diagonally. So I want this guy here. So I'm going to move this guy up. I want to get it, and you cannot trap your variable on the bottom. So this is something we'll do a lot of. So I'm going to move this guy up here, okay, and then I'm going to move this guy over here. So let's put put the numbers in. You can see it a little better. So it's going to be $22 per 1 hour equals, okay, $5,000 over an unknown amount of time. So I'm going to move this guy up top here. This is my variable I'm looking for. So it's going to go, in this case, 22 hours up here, unknown value. And then move this guy down here to get onto that side, and move this guy up here. So I'm trying to get the variable I want all by itself. So I'm going to go, this is now going to be hours equal, I'm looking for, equals 5,000 times what happens to be 1 hour, times 1 hour, divided by the 22. The 22 got shot down here. And now I can solve for that guy. You might think that's a lot of work, but really it's just moving things diagonally, and you'll find that that should make sense. 5,000 times 1 divided by 22. And it's 227 hours. Okay? 227 hours. So we've introduced some stuff here. Now this math, moving things diagonally, works splendidly in chemistry, and people use it all the time. It makes math easier. We almost never have addition and subtraction, so be careful of that. Okay, this is the end of our just general introduction to factor label. Thank you very much.